Okay, Assalamualaikum and hi everyone. So for today, on behalf of the co-authors, I would like to present our paper with the title Severity Classification Using Deep Learning for Diabetic Retinopathy. Diabetic retinopathy is a condition with progressive retinal damage caused by a microvascular complications of diabetic mellitus, which eventually can result in vision loss. Diabetic retinopathy (DR) is the main cause of blindness in worldwide. According to the World Health Organization (WHO), more than 75% of patients who have diabetes for more than 20 years will have some form of DR. Meanwhile, according to the National Eye Survey in Malaysia, DR was the cause of blindness in 10.4% of Malaysian older persons. Okay, so DR is very hard to be detected in the initial stage. The manual diagnosis take around 3 weeks, so the procedure of diagnosis can be time consuming even for the experienced expert. Okay, actually, diabetic retinopathy can be categorized into two categories. The first one is NPDR and PDR. So the main focuses in this project is NPDR, non-proliferative diabetic retinopathy. In NPDR, actually, we can categorize into several more stages. Okay, we can have mild, moderate, and severe. In the mild stage, okay, uh, there are the lesson that may present in the mild stage is microaneurysm, which is the reddish in color, smaller in size and circular in shape. Meanwhile, for moderate, multiple microaneurysm may present, and dot and blot hemorrhage, venous bleeding, and cotton wool spot. Cotton wool spot is actually the yellowish, the yellowish region objects look like this here. Okay. Meanwhile, for the severe case or severe stage, several lessons that may appear, such as cotton wool spots, venous bleeding, and severe intraretinal microvascular abnormalities in one or more quadrants. Previously, there are a few machine learning approaches that had been used, for example, support vector machine, neural network, and so on. In this project, we would like to explore deep learning approaches in order for us to classify diabetic retinopathy. Okay, so here, based on the review, okay, several deep learning approaches that have been implemented, and one of this is a CNN, which can achieve until 97.5% for Macedo dataset and 98.02 for IGRID dataset. Okay, so the Macedo this author just implement into two dataset. Okay, so meanwhile, for in our project, we will use different data set and then different CNN architecture as well. Okay, so here in this project, we will use Kaggle Aptos 2019, which contains 3,662 high-resolution fundus image, and Direct DB1, which contains 89 color retinal fundus image. Okay, so this is the overall flow chart for this project. Okay, we start with the input RGB image, and then it will be passed through the image preprocessing. Here we implement contrast adjustment and image filtering, and then segmentation, which we implement local entropy thresholding, followed by classification and performance measurement. Okay, so this is a sample of original image, which is RGB color image, and then we have different planes, which is green plane, red plane, and blue plane. Okay, so here actually we will use the green plane for our process onwards. Okay, so we can see here that green plane produce more informative structure of the vessels, of the lesson, and so on, when compared to the blue and red plane. Okay, for a for pre-processing, we will implement several methods. For example, we implement histogram equalization and contrast limited adaptive histogram equalization. These two methods actually is used for contrast adjustment. Meanwhile, for unsharp masking, is more towards to sharpen the image. And for the local thresholding based segmentation, in this work, we will implement local entropy thresholding. Local entropy filter can detect small changes in the gray level distributions in the given area. Based on the pixel intensity values and the encode the gray value distributions in local area in binary and return the encoding minimum value. Again, for classification, using convolutional neural network, in CNN, they have several layers that will uh, implement for specific purposes. For example, for convolutional layer, this is the first and foremost layer laid after the input image, which want to be classified, followed by pooling layer, dropout layer, fully connected layer, and softmax layer. In this work also, we will use pre-trained CNN, which is ResNet 152 version 2 model and Inception version 3 model. Okay, for the first model, ResNet 152 version 2, it has 152 layers. Meanwhile, for the Inception V3 model, we have 48 layers. So for result of the discussion, we will show you a few samples images after pre-processing, segmentations, and the final classification. Okay, so for the first process is pre-processing. Okay, for the contrast adjustment, we implement two methods, which is histogram equalization and Clahe. So for both of these methods, actually the main purposes is to adjust the contrast. So based on this, we can see that histogram equalization produce brighter image compared to Clahe. Okay, and then when we want to sharpen the image, we embed unsharp masking. Okay, so these results show the histogram equalization with unsharp masking, and then this is Clahe with unsharp masking. And then we try to implement try to implement the performance evaluation. Okay, based on the performance evaluation, we can see that the combinations of Clahe and unsharp masking produce a better result compared to HE and unsharp masking. So for this point onwards, we will implement Clahe plus unsharp masking. Okay, and then for image filtering, we try to implement two methods, which is Gaussian filtering and median filtering. Okay, based on these result, we can see that median filtering produce a better result compared to Gaussian filtering. Okay, so this is the samples resulting image after we implement local entropy thresholding. Okay, so this is sample for normal image, mild image, moderate, and severe. Okay, so let me take a look into here. Okay, so for normal image, we can see clearly the vessels, and then for the mild NPDR, we can see the dot for the microaneurysm, and then for moderate, we can see the more distinguished regions. Okay, and for severe, we can see a lot more, which is vessels, hemorrhage, microaneurysm, and exudates everywhere. Okay, so then we try to implement parameter tuning in order for us to get the optimized parameter to detect, to classify the severity of the DR. Okay, so we try to implement several combinations, and based on the training and validation testing accuracy, we implement the learning rate 0.001 with batch size 32 with Adam optimizer. We obtain training accuracy up to 99%, validation accuracy 96%, and for testing accuracy 90%. Okay, so based on the result, we can see that uh, common misclassifications happen between mild and moderate NPDR. Okay, this is might to maybe due to the features of microaneurysm and hemorrhage have similarity in shapes. And meanwhile, for we try to implement to different models. For example, here, ResNet uh, 152 version 2 show better performance and classification with 90% accuracy, where Inception V3 obtained only 88%. Okay, so ResNet 152 version 2 model has complex architecture network and able to accept features and learn it as compared to a CNN model with only have 5 layers. Okay, so this is the overall result analysis with three models, which is CNN, ResNet 152 version 2, and Inception version 3. So based on this result, we can see that the ResNet 152 version 2 obtained the highest accuracy, and then the highest sensitivity, and the highest specificity, and as well as precision. So based on this, we can see that number of parameter trained in the model does not guarantee better accuracy. Inception version 3 model marked to have highest accuracy, sensitivity and specificity compared to CNN model. These have been proven by other researchers as well in classifications DR using deep learning model. Meanwhile, for the ResNet 152 version 2 model is found to be more satisfactory as compared to the other two models in terms of accuracy, sensitivity, specificity, and precision. ResNet 152 version 2 model consists of 152 layers which can study the details of each class in deeper as compared to Inception version 3 model which only consists of 48 layers, and CNN model which only have 5 layers. This can be proven that the DR classification require a model with a deep enough layer. In conclusion, the main idea of this project is to classify the severity of the DR using deep learning, and then we implement in order to implement the classification, we have several pre-processing stages. For example, we have pre-processing and segmentation. Based on the result, we can see that the combinations of Clahe and unsharp masking provide outstanding result when it improves the sharpness of the fundus features and preserve the defined details of the image. And then for filtering, median filter provides significant effect in removing the unwanted noise. And then for the local entropy thresholding, it's able to segment the retinal lesion based on the pixel intensity values. And last but not least, in terms of classification, based on based on the parameters used for neutral network training, such as learning rate, batch size, optimizer. Okay, we can see that in overall, the ResNet 152 version 2 model can be said as the better classifier model when compared to the other two models. Okay, so the strength and limitations of the project is this study enabled the detections of DR to move forwards to the advanced era by replacing the manual detection with higher automated technology. Having automatic classification method proposed in the study also allowed the detection of retinal lesion in the DR image to be more precise, and it can help the ophthalmologist to reduce the workload and time. Meanwhile, the main limitation in this work is the dataset imbalance, and then the segmented lesson features of the microaneurysm and hemorrhage have similarity in shape, so it also affect the accuracy for the stages. That's all for my presentation. Thank you.